Got it. Hello, assalamu alaikum. Today we will discuss about the problem. See Riverside Curio. This problem is taken from the PK Cup 2018 round two. At the first, let's read the problem statement at the first time, and then we talk about the solution approach of this problem. Acrody decides to observe a river for n consecutive days. So, what is the data we have provided at the first time? We have n consecutive days. We have total n consecutive days. The reverse water levels on each day is equal to some real value. That means we have a river, and we have to observe it in n consecutive days, and every day the water level of the river will be in some level. This is always some real value. So, Arcady goes to Riverside East and makes a mark on the side of the river, side of the channel at the height of the water level. But if it coincides with a mark before, no new marks is created. The water does not wash the marks away. Arcady does not. Arcady writes down the number of marks strictly above the level of east. This is the one important observations line. Mark the water level. Each strictly marks water level is day, and the ith day the value is equal to mi, and the height of the water level, but it considers the mark before no new mark is created. The water does not work the marks is strictly above the water level of east. That means the height of the river is the water level of the river is changes day by day, we know that. And she tried to mark the water level day by day, and each day he will count the number of water mark he gave. The number of water mark is given by him, uh, that is situated above the water level. And at the first time, let's consider at the ith state, there this is an watermark. And next step, or I plus one step, if the watermark is at the same level, then we do not consider that. We will have to add another watermark, and then we can consider it, we can give a watermark. So let's go to the problem statement. Define di as the number of marks strictly under the water level. So what he will be observed that the number of water mark it's situated at the above of the water, and the array d represent the what number of water mark situated at the above level of the water. So this is another important line to be marks strictly under the water level of the ith day. You have to find the minimum possible sum of di over all the days. uh, this is our main requirement. We have to find the minimum possible sum of di over all the days. So from the problem statement, what we can understand, we have n total consecutive days, and every day uh, water level of the river is reached at the different heights. And if the two consecutive days contains the same watermark, we cannot consider it as the newly marked level. This is situated as like as this way. If at the ith day water level is marked as this one level, and I plus one level, if this mark is not added, we cannot consider that newly mark is added in the rivers. And what he will be observed, he will observe the number of water marks is situated above the water level, and another array d which will represent the value is situated under the water level. We have to detect the minimum level of sum which is situated under the water level. And the water, we do not have to be worried about the water washed the watermark, as we as this problem statement represented. This problem statement said that the watermark is never be washed by the water. So let's solve some example, then we can understand the problem very easily. At the first time, take this problem. This is our main array, 0 1 0 and 0. So at the zeroth day, we have initially we have no watermark. For the day one, we add this watermark, and our water is situated in this level. Is this complete level? In this complete level. So at the day 2, we have one more watermark above the water level. So we have to add one more watermark, so that we can represent this filter with we can represent this watermark by the another watermark. So at third day, we have no above watermark present at here. So what can we do at here, at the next step? And every step we can add a single watermark. As the next step contain three watermark above the water level. So in this step we need to add one more watermark, so that at the next step we can verify our conditions. So for the next level we have three watermarks. This is our watermarks: one, two, and three. And as no watermark is situated above the watermarks, so our value will be situated at this way. Our water will be situated at this way. Next, to go for the depth 4. For the depth 4 we have three water mark above the water, so we have to add one more watermark, so that the condition will be verified. So we will add one more watermark at here. And three watermark is above, is on the above line, so our water level will be held at this state. This whole state will be covered by the water. For the next step, no watermark is situated at the above of the water level, so we does not need to aim at any more water level. We can continue it with the four water mark. This is our four watermark, and the water is covered by this all the levels. Now go for the next day. This is the here this says that we have two watermarks above our water line, above our water level. So we can continue this with this four watermark also. No need to add one more water level, or one more watermark. We have two watermarks above the level, so this water level will be covered by this watermark, these two above watermark. So what is the number of watermark is situated under the water level? So at this step no watermark is situated under the water level, so at this step no watermark is situated. This step is same, and this step, and in this step we have two watermarks under the water level. And in this step we have no watermark under the water level, and in this step we have three watermarks situated under the water level, and in this step we have only one watermark situated under the water level. So if we take the summation of this d array, this represent by the array d, according to our problem statement. So what is the summation of this array? This is 6. That means we have total six minimum possible watermarks that is situated under the watermark. So our answer is 6. We can see that if we solve this another problem, we can see that at the first level, at the first we add one watermark, and our water is situated under that. And the next day we have only one watermark is situated above the water level, so we have to add another watermark, so that the condition will be verified. So our water is situated at this level, and the next day two water mark is situated above the water level, so we have to add another watermark, so that our condition will be verified. This is our three watermark, and our water level is situated at this state. This will cover this under area, and This above two water is situated under the water level, above the water level. And 0 1 and 2, and the next day one water mark is situated above the water level. So we does not need to any add any newly watermark. We can continue with this three watermark also. We can continue this with this. We can continue with this three watermark. So this is our fourth level. That means water will be covered by this portion. That means this two watermark is covered by the water. And if we have to detect the strictly under the water level, uh, strictly under the water level, so that's why we cannot count the level that is covered at the neck point. We have to count the water level, water covered the watermarks deeply. Then we have the two water marks instituted above the water level. So we can continue with these three watermarks. We can continue this with three watermarks. So our water is situated at this place. Now, if we take a count of the D array, that means the water marks is situated under the water level, strictly under the water level. This is this part take 0, this part take 0, this part take 0, this part take only 1, and this part is 0. What is the summation of this array? That means 1. This is 1, and that means that the minimum summation of the array D is 1. If we try to solve for the another problem, this is 0 1 1 and 2 2. At the first day, our we have only one watermark, and our water is situated at till this level. Next day, we have only one watermark that is situated above the water level. So we have to add another watermark so that this condition will be verified, and water is situated till this. For the next day, we can continue with this two watermark or two watermarks. So if we add another watermark, that will be no problem, but we can continue with this two card. And next day, two water level or watermark is situated above the water level. So we have to add another watermarks at here. So we add three watermarks to verify this condition. And our water is situated at this level. And next step is two for so we can continue with these three watermarks also. And this is our three watermarks, and our water level is situated at our water level is situated at this step. So how many watermarks is under the water level? This is 0, this is 0, this is 0, and this is 0 and 0. So we have total 0 watermark situated strictly under the water level. So the minimum possible sum of the array D is 0. We can see the answer is 0. So this is the main requirement of this problem. We have to detect this minimum summation of the array. So let's come in some observation. What we can see that we have to detect, we have to take the water at in ith level. We have to take two decision. We will we add another watermarks at here, or we will continue with this previously taken water levels. Because at this state we have to take one watermarks. Why? Because at the next step we have to keep one watermarks is strictly situated above the water level. That's why we have to take one watermarks at here, because at the next step we cannot add more than one water at a time to satisfy our condition. We can add only one watermarks to satisfy our conditions. So that's why we have to take we have to take one watermarks at the process state. This is same for at this state and this state. And at the fifth state, we continue with these four watermarks because we can satisfy this condition. We can satisfy this condition with these four watermarks, and our next day condition will be also satisfied with these four watermarks. So we have to take a decision that will take our will take or continue. How many watermarks we can add at a time? Only one. So we will check this condition also. So what's the thing we have to make build at here? If we mark the note 010 010 302 010 30 and 2. What we can see at here, at this state we can use only one watermarks, and in this state we can use two watermarks, and in this state we can use three watermarks, and this state we can use four watermarks, and this step we can also continue with this four watermarks. And this is the total water marks we can use at here. So what is the what is the level that is situated under the strictly under the water level? If we deduct this value from this space, we can find that levels. So what is the strictly sum at here? This is 3 1 2 3 4 10 14 and 18. If we deduct 17 15 14 10 9, if we deduct 18 minus 3 is 15, 18 minus 3 minus 1 minus 4 minus 1 minus 2 and minus 1. So what will be the result? What the result come at here? This is 6. So one thing we can find from this solving problem, that is the answer is 6. We have to build this array from here. So did we count do we count from the at the first level? No, we will count from the last level and go from right to left. Go from right to left. So what is the watermarks at the initial level? At the initial level we have no watermarks. So we will consider that we will add one watermarks from the previous state. We'll always try to count that we will add one watermarks than the previous step. And at the next step we will deduct one from here, because we will add one watermarks at the next step. So what is our standard formula? At the first level, water at the first state water level is 0. As we start at the initial state, we will count that the value of WL, we will consider that max of 0 and WL minus 1. That we will what is this mean? This mean that we will use another at the watermarks at the next level, and we will deduct one at this level. So what we have to count at here? Next we have to find that we continue with the previous state. We will add the watermark, this is WL. And what is if we try to cover up this present state, what will be the situation? This will be the mi plus 1. That mi needs to mi water levels we have to cover, and plus we will add one water level at here, mi plus one. And we have to remember these water levels in a dp array, one array or one storage which we will consider as the dp storage. What we will have to find then, we we will get, if we use this formula, we will get 0 1 0 3 0 and 2. So as we start our journey from here, so what will be the water level? Initially is 0, so 2 plus 1 3, and at this state watermarks it become 2, 2 and 1, this is 2, and in this state 3, from 2 it will become 1, and 3 plus 1 is 4, so the value will be 4, and at this state this will be 3, and 0 plus 1 is 1, so maximum is 3, and is in this state it will become 2 and 2, and in this state the value will be the 1, 0 plus 1 is 1. That means it represents the minimum number of water levels or minimum number of watermarks need to satisfy this condition. So what we'll next have to do, we will use one watermarks at here, we use two watermarks at here, we use three watermarks at here, we use four watermarks at here. As we cannot remove watermarks from the river, so we will continue at here with 4, and we will continue the river with the 4. Then what we have to do, we have to count the total number of watermarks we use at here, which we'll see at the this example. So what is the assumption? The assumption will be 18. Then we will deduct mi plus 1, because to fulfill this condition we need to take mi plus 1 options situated above the water level. So count the water level under count the water marks situated under the water level. We have to deduct mi plus 1 or upper portion to remove, as we have to count the strictly under the water level. So mi water is above the mi water marks is situated above the water level, and 1 is situated at the nick point. One water mark is situated at the nick point of the water level. So next point is situated under the watermarks, and the we will deduct it from the total watermarks, and every step we will deduct mi plus 1 from the total collection. So what will be the common result come here? 1 2 1 4 1 and 3. So what will be the output? 18 minus 1 minus 2 minus 1 minus 4 minus 1 minus 3. This is 6. And if we use this formula for the next example, what will be the result? 501. Is it charging? Okay. Uh, 0 1 2 1 2. 0 1 2 1 and 2. 0 1 2 and 1 2. Okay, that's very fine. And initially we have no watermarks, so at this state we our initial value was 0, it will become 3, and at this state it becomes 2, and value will be 2, and this is in this state watermarks will be 1, because we consider that the next watermarks is one watermark is added at the next level. So what will be the value? The value will be 3. 3 watermarks need to complete this condition, and this state it becomes 2, and what will be the water level total watermark situated at here? This is 2, and this level watermarks will be 1, because 1 is added at here. 0 plus 1 1. So our total condition will be situated in this level, and if we see at the original state, one water we will use one watermark we will use at the first step. Next we will use two watermarks, and next we will use three watermarks. As we cannot remove watermarks, So this day we will have to continue with these three watermarks, though we need only two watermarks to satisfy our condition, but we will have to use one watermarks, extra watermarks at here. And in this level we will continue with these three watermarks. What will be the summation of this array? If I take the help of calculator, this will be this summation will be get 12. And to deduct mi plus 1 at this level, 1 minus 2 minus 3 minus 2 and minus 3. What will be the summation? Borrow minus x minus 2 minus 3 minus 2 minus 3. This will be the 1. And this is our wanted output. We will use this formula for our next example. This is 0, 1, 1 and 2, 2. 0, 1, 1 and 2 and 2. Our initial level watermarks is 0. This will become 3 at here, and this in this step this will be used, this will be 2, because we will add one water level at the fifth step. So this will be 3, and this will be 2 at here, and this will be continue with 2, and this will be 1 at here, and this will be 2 at here, this will be 1, and final at the 1th level we will have to continue with 1 watermarks. So what will be the situation actually, or we the situation actually 2, 2, 3 and 3. What is the summation? The summation is, if I take the help of calculator, this is 11. And what will be the deducting result? 1 minus 2 minus 2 minus 3 and minus 3. What will be the result? 11 minus 1 minus 2 minus 2 minus 3 minus 3. This will be the 0, which is our wanted answer. So let's try to implement this problem. What we will have to do first time, we will have to detect this array, this wanted array. So we will mark it as just for safety. I can take long variable, or dp length as n. Dp length is n because we have n consecutive days, and at the initial level, long guard, initial level we have 0 guard. We will start iteration from the end of the array, and to move from right to left of the array, and to start to iterate right to left. And we have to deduct one watermark at the each level. Watermark cannot be negative, so we have to take this condition. And what will be the actual result of the guard? Map dot maximum of, can I continue with the number of guard taken at the previous level, or we have to use one extra guard at here? This is our condition. We will use, we add one at here because the nick level guard we cannot consider as the situated above of the guard. So ai plus 1 guard is added, and this guard number is remembered by our dpr guvrt. uh, Now what we can get, we get this array, but what we need to make this array to this array. So we have to count the maximum number of guard at the each level. Max is 0, as equal to 0. Max of dp of I, and max dp of I is equal to max. So we get this array to check this. I run with our first example. Compile this code with my first example. Print. Oh, sorry. I use integer right here, but our wanted answer is long. But I give long at the previous answer. One, two, three, four, and four. So we will get our wanted array. What we will have to do at the next level, we have to detect this summation of this array, which will represent that the total number of watermarks we will use at here. So total watermarks is equal to 0 for long of I dp total water mark plus r is equal to I, and what we have to deduct, we will deduct the number of water situated above the water level and the number of water marks situated above the water level and the number of water marks situated at the neck level of the water. So total water mark minus r is equal to fi plus water. So what is the water situated under the water level? Water mark under the water level is the this variable total water mark. So just print this variable at here. System.out.println water mark under the watermark under the water level. So what is the result we can get at here? This is 6, which satisfy our first example. Now I compile with my second example. This is 1. This is also satisfied. And now I compile this with my third example. Also satisfied. I just compile again with my first example. This is 6. That means the sample test cases of this problem statement is satisfied. Now I submit this problem so that this can find that any corner case is situated or not. This will take some time. So, uh, this is start to judge this problem. Running on test 1, reload, accepted. So at some last video, at the last video, someone requested me to make some video with English. So that's why I make this video in English. And uh, if I think that this is valuable or helpful for all, I will make more videos in English, and I try to make the videos of the latest code forces round after giving the standing or rating, because some extra test cases will be tested on my solution. So if something is wrong in my solution, so that is problem. So I will publish the videos of the latest code forces round after giving the rating of the code forces. I hope everything you can understand. But if any confusion, you can feel free to ask me at here. So